Hi, and welcome to this tutorial session. Today we want to handle this question under the topic functions. A function f is defined on the set of real numbers r. All right, as we see, f from r to r, that takes x and maps to 3x all over 5x minus 2. A, state the domain of f of x. All right, and state the domain of f of x. Then B, investigate if f of x is bijective. Okay, so please follow the solution from the beginning to the end and tell us if there are any issues that you want us to address. We have the function f. The domain is a set of real numbers, codomain set of real numbers. It takes x and maps to the expression 3x all over 5x minus 2. Okay, so now we want to state the domain of the function. We want to state the domain of the function. Now, this is a rational function. All functions that have a numerator and a denominator are called rational functions. And such functions are not defined for any situation of this nature, that there is a non-zero numerator and a zero denominator. Such functions are not defined for any value that will render the denominator 0. So which are those values of x that will render 5x minus 2 0? All right, so to get those values, we set 5x minus 2 equal to 0 and solve. All right, we have 5x is equal to 2. That means x is equal to 2 all over 5. So this is the only value. If x takes the value 2 all over 5, then this denominator will be 0. And so it will render this expression undefined. So f will take any real value except the value 2 all over 5. So the domain of f now, domain of f will no longer be r, all right, will be all real numbers except the singleton 2 all over 5. So if we're asked to redefine this function, then we'll redefine it as f with domain r except 2 all over 5, all right, to r that takes x and maps to 3x all over 5x minus 2. If we were to define this function in the right and proper manner, this would have been the right definition. Okay, so this function defined as such is not correct. This is the right definition. We found the domain of that function. The domain is actually all real numbers except 2/5. All right, now the second part of our question, it says investigate if the function is bijective. We want to investigate if this function is bijective. All right, so our function is f of x is equal to 3x all over 5x minus 2, where x should never take the value 2/5. All right. So we want to investigate bijectivity. A function f is bijective if it is both injective and surjective. Let's take injectivity. Is this function injective? What do we mean when we say injectivity? The function f is injective if for any two values, x1, x2, from the domain of our function, if f of x1 equals f of x2, therefore x1 equals x2. Okay, that's the condition. If this function satisfies this condition, then we will say the function is injective. All right, what is f of x1? That means in the place of x, we put x1. We have 3x1 all over 5x1 minus 2. What is f of x2? In the place of x, we put x2. 3x2 all over 5x2 minus 2. Now, f of x1 equals f of x2. What is that? We'll take this, equate to this. So we're saying 3x1 all over 5x1 minus 2 is equal to 3x2 all over 5x2 minus 2. So we work with this to see if we can produce this. All right, so this here is it. We're working with it. Can we arrive at x1 equals x2? Let's go and see. This expression is rational. This one is rational, so we can carry out cross multiplication. All right, this denominator multiply out that we have 3x1 into 5x2 minus 2. This denominator multiply to that numerator 3x2 into 5x1 minus 2. That's what we want to see. Now, if we open out the parentheses, we're going to obtain 3 multiplied to 5, 15. 15x1, x2. 3x1 multiplied to negative 2, negative 6x1. We'll open out these parentheses to have 15x1, x2. This one multiplied to negative 2, negative 6x2. So if we look at it carefully, we have 15x1, x2, 15x1, x2. They are on both sides of the equation, so they cancel out. All right, they cancel our level what? Negative 6x1 of negative 6x1 is equal to negative 6x2. Okay, so we have negative 6x1 equals negative 6x2. We divide both sides by negative 6 divided by negative 6 divided here by negative 6. You see they go off, so we end up with x1 equals x2. All right, so we have finally shown that if f of x1 equals f of x2, then x1 equals x2. All right, we started there and we have ended there. So conclusion, f is injective. So that function is injective. Now let's check the other property, surjectivity. Is f of x surjective? Let's check if f of s is surjective. Now, surjectivity. What is the property surjectivity? The function f is surjective if for every element in its codomain, all right, we can find an element x in the domain, of the function f such that y is actually the image of that element in their domain. All right, so this is a property for surjectivity. F is surjective if for every element in the codomain there is at least one element in the domain such that that element in the codomain is the image of the element in the domain. All right, so it means that what we're working with this to see if we can find an x in the domain for which this will always hold all the time. All right, so we have y equals f of x, but we know f of x is 3x all over 5x minus 2. So we're saying y is equal to 3x all over 5x minus 2. All right, can we get x? All right, there exists. Can we get an x from the domain of x that this will always be? All right, so let's make x the subject here. So we have this. If we cross multiply, this is a fraction. We can make this one a fraction so that we carry out cross multiplication. All right, y multiplied to all of that. Y multiplied to 5x minus 2. 1 multiplied to that 3x. We want to make x the subject. Open out this parenthesis to have 5xy minus 2y is equal to 3x. Bring all the x's to one side. Take this one this way. We'll have 5xy minus 3x. We take this negative 2y that way, become positive 2y. All right, so now, we see x is common here. We'll factorize out x. If we factorize out x, we'll have 5y. Factorize out x, we'll have negative 3 is equal to 2y. Now, divide both sides by 5y minus 3. All right. Divided by 5y minus 3 divided by 5y minus 3. All right, this cancels off. So we now have an expression for x. X is equal to 2y all over 5y minus 3. All right. When we get to this level, what we have to do is to check for ourselves. X is from the domain. What is our domain? Our domain again is what? All real numbers except 2 all over 5. All right. X is from the set of real numbers except 2 all over 5. All real numbers except 2 all over 5. And our y is from the codomain. Y is from all of R. Okay. So are we saying that for all real numbers that are here, we're always going to have an element from this domain such that this is the image of that element when we consider the function f of x? In other words, are we saying that for any real number, because y here stands for any real number, for any real number, we are always going to have a result which is in this set. A result which is in this set. That is not true. We can see that is not true. All right? There will be a value for y that will render this denominator 0. All right? And that value is a real number, but you see that it will not be found in this set. Okay? All right, so let us see. If we set that denominator to 0 and solve for y, we obtain y equals 3 all over 5. Now, this means that what? When y is 3 all over 5, all right, we will not have any x. We will not have any x. Remember, y is any real number. 3 all over 5 is a real number. Y is any real number. That means we can put this value there. But we'll put this value there. We'll put 3 all over 5 there. We'll obtain an undefined expression. Let's put it and see. Let's put it and see. If we put y equals 3 all over 5, okay, in the expression x equals 2y all over 5y minus 3, what are we going to get? We have 2 into 3 all over 5 all over 5 into 3 all over 5 minus 3. All right, this will give us 6 all over 5 divided by, or let's put it like that, divided by what? 5 here cancels, 3 minus 3 is 0. Any number divided by 0 is infinitely above human capacity. It's undefined. All right, so what are we then therefore concluding? We are seeing that what? There is actually a certain value of y which is not the image under the function f. All right, there is a certain value in the codomain that has not been mapped into by f. But look at our definition of surjectivity. It says for all values of y, all values of y, all. But here we have found a certain value of y which makes our expression undefined, which makes x undefined, which makes x not to exist. So this therefore concludes by saying that what? Conclusion simply means that f is not surjective. So the function f is not surjective. So what is our general conclusion? Now remember, we're asked to investigate bijectivity. All right. For a function to be bijective, it must be injective and surjective. So conclusion, we have F, which is injective, but F is what? Not surjective. Conclusion, F is not bijective. The function F is not bijective.